Okay, so this is question 9b from the practice final, and this is the case where you've isolated 4 mutants that all give basically the same phenotype. All of them have increased sensitivity to a drug called bleomycin, and which is a DNA damaging agent. So presumably these are genes that are involved somehow in DNA damage repair. So we have these mutations, and in order to measure the sensitivity, we measured the concentration, the plates on which the concentration of bleomycin can still support their growth. And so for the wild type, we see from this table here that the wild type strains can grow on plates that have 100 micromolar of bleomycin. So they're fairly resistant to this drug. Whereas the singles have a more modest, they have a modest sensitivity to the drug, and they can grow on amounts that are 50 micromolar. So now we want to know, of our 4 genes, which ones function in the same or different pathways, and which pathways might be functionally redundant. So if we look at our table, and we look at the different combinations of double mutants and the different outcomes of what plates what sensitivity they have to bleomycin, we look at these different concentrations they can grow on, and we can see that there are basically 3 classes of mutants, of double mutants. So if we focus on the 2 that stand out, we have this, BLS1 and BLS3, and these actually, so these have the same phenotype as the single mutants. So if we have a double mutant that has the same phenotype as the single mutants, then we can say that these 2 genes, 1 and 3, that they act in the same pathway. Okay? So over here, I just wrote them as 1 and 3. If we look at the other double mutant that stands out here, we see that BLS1 and BLS4 have a very severe, they can't grow on any plates that have bleomycin in them, so they only grow on plates with 0 micromolar bleomycin, so they're very sensitive. So if we have, this would be a synthetic phenotype, more severe than either of the single mutants. So in this case, we would put 1 and 4 in different pathways, and we would also say that those are functionally redundant pathways. Okay, so we'll put them with arrows kind of going, leading into that same pathway. Now we have this other class here, which are more moderate. So they're reduced, but they're not reduced all the way down to 0. So it's not that they don't appear to be working in the same pathway. They don't seem to be working in redundant pathways. And so what likely they are, they're just mutations in genes that are functionally unrelated to one another. And so all of these involve BLS2. Okay, so this would say that BLS2 stands apart from the other mutations, 1, 3, and 4. And so we would just put it over here on its own. So this is a part of a gene network that you would build that describe the sensitivity to the bleomycin. Okay, so the last part of the question asks you to predict the phenotype of the BLS3, BLS4 double mutant. So if we were to look at our pathway now, we could infer what that phenotype might be. So we know if 1 and 4 are functionally redundant with each other, and we know that 1 and 3 are in the same pathway, then we can infer that 3 and 4 will also be functionally redundant. And so we would, if they were functionally redundant, then we would expect that the 3-4 double mutant will look just like the 1-4 double mutant and will not be able to grow on plates that have any concentration of bleomycin on them.